Welcome to the Technology Addicts podcast. In this episode, we're diving into an article from the latest issue of Focus magazine, exploring the exciting world of sustainable transportation. A converter for every railroad. A wide range of DC to DC converters are used on railroads. New power semiconductors increase their efficiency and help to make rail travel even better for the climate. And converters with ultra-wide input voltage make it possible to use them all around the world. There is hardly any means of transport more energy efficient than rail. According to a study by the European Environment Agency, long-distance transport is responsible for less than a quarter of the carbon emissions released by cars, and heavy goods transport comes in even lower by a factor of 5.7. As a result, railroad networks make a significant contribution to sustainability in the transport sector. Nevertheless, railroads still consume a lot of electricity. For this reason, work is being done around the world to further reduce their energy consumption. A key part of this is the traction systems. In this context, developing converters and inverters with lower power dissipation in the traction systems is crucial for reducing energy usage in rail transport and cutting carbon emissions. This is because a wide range of DC to DC converters are used in modern railroad systems to power monitoring and control units. To increase their efficiency, new high-performance semiconductor devices and low-loss capacitors are required. Today, silicon carbide and gallium nitride are increasingly being used as materials for power semiconductors. Compared with the silicon-based semiconductors used previously, they enable higher switching speeds as well as lower inductances and capacitances, resulting in less leakage current and smaller component sizes. One challenge in designing DC to DC converters for the global locomotive market is that the various rail systems are operated at different voltages. In most countries, such as Germany, the United States, France, and India, the internal control systems require a supply voltage of 24, 28, 36, 48, 72, 96, and 110 volts. DC to DC converters with an ultra-wide voltage input offer a solution that avoids having to design and manage a specific converter for each individual voltage level. They cover all possible voltages that will be used on board. The converter manufacturers had to overcome two challenges to meet the requirements of EN 50155, the internationally recognized standard for the design, manufacture, and testing of electronic equipment installed in rolling stock. First, the DC power supply module must provide a stable supply to the back-end devices within the input voltage's fluctuation range. Specifically, pursuant to EN 50155, this means that the power supply units must operate stably in a voltage range of 0.7 to 1.25 times the supply voltage. In other words, from 16.8 to 137.5 volts. To satisfy the requirements of rail systems around the world with respect to power supply and certification, the input range of ultra-wide power modules needs to be 14 to 160 volts. There are huge demands on rail transport when it comes to reliability. In the event of a power supply failure, the back-end devices must still be able to store the current status data, allowing them to switch over to the emergency power supply in the proper manner. For this reason, the power module is combined with a capacitor that ensures the required power failure bridging. Therefore, EN 50155 has defined power supply voltage interruption classes, which are divided into S1, S2, and S3. If the converter keeps the output voltage stable when the input voltage drops to 0 volts and returns to normal after 10 milliseconds, it meets class S2. If the input voltage drops to 0 volts for up to 20 milliseconds and the output voltage remains stable, it meets class S3. The standard also provides pass and fail criteria, which are divided into 4 levels. Criteria A and B mean acceptable, while criteria C and D mean unacceptable. Here the system does not self-recover from the interruption. State-of-the-art solutions combine the energy storage module with a module for automatic switching in the power failure bridging process dependent on the supply voltage. Additional energy pre-storage modules minimize capacitor volume and maximize energy storage, since reducing footprint and weight is also important in the railroad context. Thank you for tuning in to this episode of the Technology Addicts podcast. For more exciting episodes, be sure to follow us on your favorite podcast platform and make sure to check out the show notes.